In this video I'm going to talk about inscribed angles, and before we get to actual theorem about inscribed angles, we need to know what an inscribed angle is. And basically what it is it's an angle that has its vertex on the circle, and then the two sides of the angle are chords of the circle. This is a little bit different from the central angles that we talked about the other day, where remember the vertex of the central angle is at the center of the circle. When it's an inscribed angle, the vertex is on the circle. Now the inscribed angle theorem deals with the measure of the angle, so in this case it would be measure of angle ABC or angle B, and then the measure of its intercepted arc, which is arc ADC here. And we're going to look at the measures of those two things on a sketchpad file. And I want you to, at home, to look at this and see if you can come up with the relationship between the measure of what I have as the green arc, the intercepted arc, and the measure of the blue angle, which is the inscribed angle. Right now you can see there are two measures, and I'm going to move it around and see if you can see a relationship between the two. Now remember, with Sketchpad it does some rounding, so you may look at it at one time and say I think I have it, and then the next time you say your relationship doesn't work, realize that there's rounding going on. That's probably not actually 232 degrees, it might be 232.34 degrees. Same thing with the measure of the angle. Now my hope is you're starting to see that, well, if I were to take the measure of the angle and double it, I'm going to get the measure of its intercepted arc, and vice versa. If I had the measure of the intercepted arc, I could cut it in half and get the measure of the angle. And that is the relationship that we're looking for here. So on my next slide I have that in equation format. To find the measure of the inscribed angle, take half of the measure of the intercepted arc, and to find the measure of the intercepted arc, take 2 times the measure of the inscribed angle. My next theorem, dealing with that quadrilateral that's inscribed in the circle, little vocab from the other day also, and this one says if a quadrilateral is inscribed in a circle, then the opposite angles, and that's what we're going to try to figure out with our other sketchpad file. And we're going to look at the measure of angle C and the measure of angle A and see if there's a relationship. Similarly, look at the measure of angle B and the measure of angle D. So on this one, I have the measure of angle D up here. That would be this little angle. And then the measure of angle B down here would be this one. I have my opposite angles, and I want you to see if you can come up with a relationship between those two. Now I'll move it around. Obviously they're not congruent. That's one that I like to look for right away. It's not like the last theorem, the inscribed angle theorem, where one thing was half of the other. But what I'm hoping you're seeing is that if you take those two angle measures and add them together, it's going to be 180 degrees. And that's always going to happen. It doesn't matter where I put this. I can move this one. I can move this one. You know, if I move B, nothing changes because the measure of the angle is not changing. And the reason the measure of the angle doesn't change is because the measure of its intercepted arc doesn't change at all. C and A stay put. It's just where that vertex is moving. So that's why the measure of the angle doesn't change. But moral of the story here is if we have those opposite angles, they are going to be supplementary. And I put that in are supplementary, and then I just wrote the two little equations that would represent that as well. Now my last two circles, I'm going to fill them in with this kind of green color. They're both going to be green because they're related. And it says if inscribed angles intercept congruent arcs, then the angles are what? Well, what this theorem says is I know that this arc CD, and arc EF are congruent. Well, then what do we know about angle A and angle B? And I just like to throw some numbers in. Well, if this is 40 degrees, that one's 40 degrees. And if the intercepted arc is 40 degrees, that means the inscribed angle is 20 degrees. Same thing's going to happen over here, 20 degrees. Well, they're congruent. And it's not going to matter what numbers I'd put here or here. The measures of these two angles would always come out to be equal. Therefore, the angles are going to be congruent. And then on my last one, it's similar to this one, but now notice this one says if the inscribed angles intercept the same arc. So instead of angle A going to an arc and angle B going to an arc, angle A is going to arc GH, that's the intercepted arc, and angle B has the same, or the congruent, or yeah, the same intercepted arc. So then what do we know about the two angles? The same thing that we learned about the two angles over here. They're going to be congruent. So that's why I'm using this same little statement here for both of these pictures, because those theorems are very similar. And that's going to conclude the lesson portion on the inscribed angles in circles.